Every function can be classified as either an even, odd, or neither function. To determine whether something is even or odd, let's first look at the definitions of even and odd functions. A function is even first if every number x in its domain, the number negative x is also in the domain. And f of negative x equals f of x. A classic example of this would be the even function f of x equals x squared. If you look at its parabola, x squared, what you see is that the value of x gives you an output of f of x. And on the other side, if you were to plug in the negative value of x, notice how you still get the same, if I drew it correctly, the same output of f of x. Okay, so this is showing us that f of negative x gives us the same output of f of x. Now, just because x squared has an even exponent, it doesn't mean that anytime you ever have an even-powered exponent, it's always going to be an even function. It just so happens to be in this case. Keep in mind, we can transform this x squared, we can move it around, and it may no longer be an even function. Okay, so in other words, in an even function, if you have every point xy on the graph, then you also have the point negative x, but then you still have the same y value, so positive y is also on the graph. The point negative xy is also on the graph. A function is even if and only if its graph is symmetric with respect to the y-axis. If we take a look at our graph of x squared, you can see if we draw a line of symmetry along the y-axis, we have that symmetry occurring along the y-axis. All right, let's go now to the definition of an odd function. A function is odd if for every number x in its domain, you also have the number negative x also in the domain. If you plug in the value of negative x into the function, you will get a negative output. You'll get the negative value of f of x. Again, another very classic example of this is looking at the odd function f of x equals x cubed. Again, just because you see a 3 there, you think 3 is an odd number. Yes, that's true. It is an odd function, but if you were to transform that x cubed, if you were to shift it left or right or up or down, you may not end up getting that odd function again because you have moved it. Okay. Now, if we look at this function, though, graphically, if you plug in the x value, you'll get its positive y value, f of x. However, if you plug in the negative x value, then you'll actually get a negative output. You'll get the negative value of f of x. And for that reason, x cubed is going to be an odd function. So you see here what this point we labeled here is that you have the point xy, which is represented here. You will also have the point that's down below in quadrant 3. That point is going to be negative x, negative y. It's also on the graph. A function is odd if and only if its graph is symmetric with respect to, notice how we have that symmetry occurring this way now, with respect to the origin. Okay? Now, discussing a little bit more about symmetry with respect to a particular axis or point, we did discuss that in chapter 1, so I just wanted to show those similarities. Recall, in chapter 1, we had tested for symmetry algebraically. And we tested it in 4 different ways. We could test for symmetry with respect to the x-axis. And if we had to test for symmetry with respect to the x-axis, we had to test the point x, negative y. If we wanted to test for symmetry with respect to the y-axis, then we had to test the point negative x, y. If we had to test for symmetry about the origin, then we had to test the point negative x, negative y. And if we had to test for symmetry about the line y equals x, we had to test the point yx. Well, there are similarities between the even function, which is symmetric to the y-axis, If it's symmetric to the y-axis, notice we're testing the point negative xy. If that point was on the graph, then it was symmetric to the y-axis. And look at this, we do see negative xy is on the graph of an even function. So therefore, that's how we know that we're testing for that symmetry along the y-axis. Also, if a function was odd, we saw that it was symmetric about the origin. And if it was odd, we saw that if you plug in negative x into your function, you get the negative y value. So you get that point, negative x, negative y. Well, look at our test for symmetry. If we test about the origin, we get the point, negative x, negative y. Same point right there. Okay, so I just wanted to show that relationship about what we did in chapter 1 with what we're doing now. Let's determine if functions are even or odd now based on our definitions. Remember, if we know that it is an even function, then what we should see is that if you plug in a negative x value, you get a positive y value. If a function is odd, then what we should see is that if you plug in a negative x value, you get a negative y value. So those are the two things we're looking for. If you don't satisfy any of those, then that would be a neither type of function. So let's take a look at these three examples here. If I plug in an x value, notice here in this case, I'm getting its positive y value, its positive output. And if I plug in on the same end, if I plug in negative x, then you'll see here, I'm still getting the same value. It has that symmetry with respect to the y-axis. Therefore, this would be an even function. Okay? Let's take a look at our next case, letter B. If we have symmetry with respect to the y-axis, we have that even function. Well, do we? It doesn't look like it. If we plug in an x value and get its output, and plug in its negative x value, do we get the same output? No, we don't, right? We're not even getting the same y value. So therefore, this is not even. Also, you don't have symmetry with respect to the origin. If I plug in this point here, I'm not seeing the mirror image over on this side here. I'm not getting that same point. So this is also not an odd function. This would be a neither function. Okay? So we're not getting that negative f of x value that we want. In example C, what we see here is if we plug in an x value and we get its output, f of x, if you plug in this negative x value, you see you actually are getting a mirror image of itself on the other side, right? You're getting it symmetric with respect to the origin. So therefore, this is going to be an odd function. Okay, so those are going to be our definitions of even, odd, and neither functions.